Okay, so let's now consider this exercise. Okay, so use Thevenin theorem to find this current. Okay, so the first parameter, so for Thevenin circuit, okay, what you need to do is to find the parameters of RTH and VTH. So this is your circuit. Okay, so VTH and RTH, and this is your terminal A, B, which is this is positive, negative, and we consider that 4 ohm is your load. Okay, 4 ohm. So we need to find this current. So, but the first one is actually you need to find this VTH and RTH. So let's start with the RTH. So to get the RTH, what you need to do is to disconnect the load and to kill all the independent source voltage. So right now the 60 volt becomes 0. So your circuit will become like this. Okay. So this is your terminal A, B. So this is 8 ohm, 10 ohm, and 40 ohm. And as you can see, the voltage source right now is actually has been killed, set to 0. Okay, so right now what your RTH is the R equivalent that since from this terminal AB. So from here I can see that your R equivalent is 10 parallel with 40 plus 8, right? Which is equivalent to equivalent to 10 plus 40 over sorry, ten multiply with 40 over 10 plus 40 plus 8. So this one should be around 400 over 50 plus 8. So this one should be 8 plus 8. So you should get 16 ohm. So this is your RTH. Okay. Now to get the V equivalence. So to get the V equivalence, okay, the VTH. So the VTH, you can actually, this is the circuit, 60 volts. You have a resistor 10 ohm, 40 ohm. This is 8 ohm, and this is the load terminal A and B. So what you need to do is actually to calculate this VOC. So this voltage is actually your VTH. So you need to calculate the VOC. Okay, so there are there is this tricky question because you may consider this one, okay? But actually, if you refer to this, if you look carefully inside this circuit, this terminal AB is an open circuit. So the current that flows into 8 ohm is actually 0. So meaning that when there is a current that flow through this resistor is 0, so meaning that the voltage here is also 0. Okay, so you can ignore this resistor because this resistor has no voltage drop. So you can actually withdraw this by ignoring this voltage, this resistor. Okay, so you can actually put your circuit like this. So meaning that right now the terminal A and B is actually equal to the voltage drop across 40 ohm. So your VOC, which is your V Thevenin, is actually the voltage across 40 ohm. And from here, you can see that this is a single loop. The current is a single loop. Okay, so you can actually simply do what I call the voltage division. So V40 ohm is actually can be found by using voltage division. 40 ohms over 40 plus 10 ohm multiplied with the voltage source. So should be 40 over 50 multiplied with 60. You should get around 48. Okay, 48 volts. So this is your VTH. Okay, so right now you have already obtained the RTH and VTH. Okay, so you need to you need to actually sketch the equivalent circuit. So this is your 48 volt positive negative and your equivalent resistor RTH, which is we have calculated earlier 16 ohm. Okay, and this connected with the load right now. The load is 4 ohm. So calculate I. So from here, then you can calculate I. Okay, so from this is a very simple circuit. So this is I. So you just use a basic Ohm's law. So I is actually 48 volt over your total resistance, which is 20 ohm. Okay, so you should get around 2.4 ampere. So that is the answer.